power law. Like, you might have to do a whole bunch of them. Then we're going to take a week off school. Then we're going to come back. We'll probably study a bit, and then we'll have a quiz. Probably a couple quizzes. Awesome. Let's start off with a nice basic one. So this guy, we have 3x squared times 5x cubed. You have three different people's answers here. We have to try to decide which one's right. I have a little saying to try to help you with questions like this. So when you have coefficients and variables, my saying is that numbers go with numbers and letters go with letters. Okay? So what that means is that if you're multiplying, which is what we're doing, numbers multiply with numbers and variables multiply with variables. For me, the numbers are 3 and 5. So 3 times 5 would be 15. Numbers go with numbers. Awesome. Then letters go with letters. So in this case, we have x squared times x cubed. When we're multiplying two letters together or two variables together, we add the exponents. So this would be 2 plus 3 to become x to the power of 5. So the correct answer is 15x to the power of 5. The person with the correct answer is Laura. If we're looking at the other two, and we're trying to figure out what they did wrong, they did a couple common mistakes. Harry messed up with the coefficients, with the numbers. So if you look, they had the x5, right? Harry did a good job there. But somehow got 8. What Harry probably did was he added the coefficients. Right? So remember, if you're multiplying, coefficients still multiply with coefficients. It's only the exponents that you're adding. What Jeanette did was actually the opposite. So Jeanette multiplied together the coefficients, did that properly to get 15, but then Jeanette multiplied the exponents together to get 6 instead of 5. Right? So when we say numbers, letters with letters, we remember coefficients multiply together. Exponents actually add together. We're multiplying the x's together. A little tricky. It's just a couple common mistakes people make. Fantastic. All right. We're not gonna. Yeah, actually, let's do this one because I want to rewrite it. So we have this question here. It says use factors to explain why 6a to the power 6 divided by 3a to the power squared equals 2a to the power 4. I'm not so worried about this part. I just want to try to answer this question and see if it's the right answer. I don't like division questions like that. I don't like this division symbol. This guy right here. To me, it messes us up usually. We're used to seeing fractions in this course. So when I see division like this, I'll change the question. I'll rewrite it. So I'll put the first part, 6a to the 6, and then divide by 3a squared. To me, that's easier to work with. So I rewrite it as a fraction. Now I can use my division law, right, and my fraction law. The same rule applies. Numbers go with numbers, letters go with letters. So in this case, the coefficients, 6 and 3, divide together. In my calculator, I go 6 divided by 3. I get 2. Then, letters go with letters. So I have a squared divided by a squared. Sorry, a to the 6 divided by a squared. I think I said a squared both times. A to the power of 6 divided by a squared. When you're dividing letters, what do we do to the exponents? We subtract them. So this one would be a to the 6 divided by a to the 2. 6 minus 2 is a to the 4. Fantastic work. All right. I'm going to tell a weird story about how people script the division rule all the time. Like this one. If they do this, a to the 6 divided by a to the 2. Yeah, they mess this up a lot. Now, I don't know why. Usually when the numbers are flipped, they mess it up. When the bigger number's on the bottom, they make mistakes. So this is how I do it. I swear this is how I do it. I play a lot of video games. A lot of video games as a kid. And I still try to whenever I can. I'm just not very good anymore. Anyways, you know when you play like war games, if you've ever played like Risk, or something like that, that you go to fight somebody else's army, and if I have like an army of 50 people and they have an army of 5 people, then 5 of my guys die, 5 of their guys die, and I'm left with 45 guys, but I won. And I get the remaining 45 guys. That's how I do fractions when I have exponents. So it's kind of weird. I visualize this as like a video game. I have a to the 6. That means I have 6 A's. Right? And they're going to go to war with a to the 2. There's 2 A's here. And when they battle, these 2 will kill 2 of those guys, and they kind of cancel each other out. These guys win the war by 4. That's why it's a to the 4. And it's on the top, because the top side won. And the reason that works for me is because when you flip it, you do something like this. A to the 3 divided by a to the 5. When you flip it and people do subtraction, it does weird things to them because they get negative numbers. So this idea of like battling each other out works for me. I have 3 in the top and they're fighting 5 on the bottom. The bottom would win because they have more. I think they have 2 more, so 2 would live. So I have nothing left on the top and A2 on the bottom. It's like a weird way to do the division rule. And if the subtraction works for you, keep doing the subtraction. If subtraction hasn't been working for you, maybe you can visualize it as just canceling out and being left with 2 on the bottom. Or 6 on the top, whatever the question is. That's my sad attempt to make video games relevant. I'll try again in the future. We'll get some Halo references in there or something. All right. Some examples of power of power. Of course, they're not power, multiple exponent laws at a time. We got this guy. So we'll start off with A. We've got coefficient and a variable times a coefficient and a variable. My rule is coefficients multiply together, numbers with numbers. 4 times 2 is 8. And then letters go with letters. X to the 5, x to the 3. They're multiplying, so you add the exponent, you become x to the 8. That's my simplified expression. Awesome. We try the second one. It's the exact same thing, they just didn't put a multiplication sign in the middle. So remember that when you have brackets against other brackets, that means multiply. Right? You can envision that there's a little multiplication symbol in it. We're going to treat it the exact same way. Okay? Coefficients multiply with coefficients. So negative 7 multiplies with 6 to be negative 42. That's going to drive me crazy. And then your letters with your letters. So I have a to the 8 and a to the 12. Because I'm multiplying, I add the exponents to become a to the 12. Fantastic. So we look at C. It's now a division question. They did a fraction. Okay, so we go numbers with numbers. That means I go 20 divided by 5. That gives me 4. I then do letters with letters. I have y to the 20 divided by y5. I'm subtracting because it's division. I'd be left with 15 on the top. Awesome. D is trickier. Okay. The reason D is going to be trickier is because of the coefficients. So prior to this question, our coefficients always divided nicely. Right? 20 divided by 5 into a whole number. If you look, this one's not going to quite work that way. So we have 30 and 45. If you go 30 divided by 45, you get a decimal. I think you get 0.66666. Oh, good guess, hey? You don't want decimals. You want fractions. So what you need to do is go 30 divided by 45, hit the math button. I'll use my dead calculator to show you where it is. Math button's over here. So remember, 30 divided by 45, enter, hit math. The very first option is frac. You hit the first option, then you hit enter again, and it should change it to a fraction for you. The fraction is 2 divided by 3. Awesome. That means our answer is still going to be a fraction with a 2 on the top and a 3 on the bottom. That's what it's telling you. So the coefficients simplified to have a 2 in the numerator, 3 in the denominator. The other way to do it, and you guys have seen this before, so it shouldn't be anything new, is you can try to look at this and simplify the fraction yourself. To simplify a fraction yourself, you ask yourself what can divide into both of these numbers. 15 can divide into both these numbers. When you divide both by 15, you get 2 and 3. That's why it works out. At the end of the day, I just use my calculator to do fractions. Way easier, in my opinion. Awesome. Now we do letters with letters. So I have b to the 14 divided by b 10. 14 minus 10 would be 4, and it'd be on the top because there's more on the top. So you have 2b to the power 4 divided by 3. Yeah. It'll go to the side that has more. So if I started with more on the top, then it sort of goes to the top. If I started with more on the bottom, then it goes to the bottom. Awesome. E. We just have 3 things multiplied together. We treat it the exact same way. So coefficients are going to multiply by all the coefficients. In this case, I have a 3 coefficient, an invisible 1 coefficient, and a 6 coefficient. If I multiply those all together, I get 18. I then can do all the letters together. So I have a to the 4, a to the 5, a to the 3. It's all multiplication, so I'm adding all the exponents up. 4 plus 5 plus 3 is 12. That would be my answer. Last one. Again, I would like to rewrite that question. I prefer fractions. So I would rather write this as negative 16 n to the 5 divided by negative 2n. Helps me visualize what I'm really doing. When I see the division symbol in the middle, it messes me up. Awesome. Now I can follow my rule. Numbers with numbers. So negative 16 divided by negative 2 would equal 8. Letters with letters. I have n to the 5 divided by n to the 1. Remember, that's an invisible 1. 5 minus 1 is n to the 4. 8 n to the 4 would be your answer. Okay, I would say that's like beginner level for us. It's beginner, maybe starting to get to intermediate. The way we can make it more challenging is that we can add in more than one letter. Okay, so that's what we're going to do next. We're going to add in an extra letter here. We're going to have X's and Y's, or B's and G's, or E's and F's. Awesome. Nothing changes. It's literally going to be the same thing, just more of the same thing. So when I see this question, I have multiplication. Numbers go with numbers. There are no coefficients, so there's no numbers to deal with. And letters go with letters, but they can only go with the same letter. So X's will go together, which usually is a scary thing, but in math it's okay. So we have x to the power of 5, x to the power of 3. You're adding the exponents to become x to the power of 8. I'm the only one who thinks it's scary when their x's get together. Cool. Then you look at your y's, right? So y's go with y's. Y to the 8, y to the 4. You're adding to become y to the 12. Awesome. It's that easy, right? It's just more of the same thing. Nothing's really changing here. As long as you understand that letters can only go with the same letter, life will be good. Looking at this guy, same idea, it's just now it's division. X's will go with x's, x to the 5, x to the 3 becomes x2. You subtract the exponent. Letters go with letters, that means y's go with y's. We have 8 minus 4 would be 4, so it's y to the power of 4. That's a y. Beautiful. A little bigger scale. So C, we've got 3 different things being multiplied together, right? Because we have brackets, brackets, brackets. We're going to follow our rules. Coefficients with coefficients, letters with letters, other letters with other letters. So as we're going through, my coefficients, negative 3, negative 4. They multiply together because they're coefficients. So it becomes positive 12. The b's. B's go with b's. So we have b to the power of 1, b to the power of 3, b to the power of 2. You're adding all those exponents. Remember, it's an invisible 1 if there's no exponent there. That means that 1 plus 3 plus 2 becomes b to the power of 6. Lastly, we have our c's. C to an invisible 1, c squared, another c to the invisible 1, becomes c to the power of 4 when you add it all up. Okay, last one. We got the issue with the numbers again, the coefficients. So 10 and 4 don't divide nicely. So in your calculator, if you did 10 divided by 4, you get a decent decimal. You get like 2.5. Right? We don't want decimals. We want fractions. So when you get 2.5, you hit math, this guy right here, math. And then the first option on your screen is fraction. So you hit frac, enter, and you will get 5 divided by 2. So your numbers, green, so consistent, your numbers become 5 divided by 2. That means our answer is still going to be a fraction. Letters go with letters. So I have e to the 8, e to the 4. You subtract, you get e to the 4 on the top because there was more on the top to start. We move on to your f's. You have f to the 12, f to the 7. You subtract exponents to become f to the 5. 5 times e to the 4 times f to the 5, all divided by 2 is your answer. Not bad, right? Awesome. So the questions you guys were doing were primarily like division and multiplication, right? Product, or quotient laws. We're going to see what to do. It's going to get a little crazy. Like the last couple questions we do are a little nuts. But we're going to look at like power of a power law, so what to do when there's an exponent outside the brackets and stuff like that, just as a reminder. And again, things don't really change, they just get bigger, right? So you just have to manage that. We'll look at this first question. We have 3x squared all to the power of 3. We learned yesterday that when you have an exponent outside the bracket, that this exponent comes into the bracket. And it goes to every term. So in this case, it's not just 3x squared it goes to, it also goes to the 3 to the power of 1. Right? So remember that 3 has an exponent of its own. It has an exponent 1 on it. When you have an exponent with an exponent, like this, what do we do to the exponents? We multiply, yeah, woohoo! Okay, so that means we're multiplying this 3 by the other exponents. That means this will become 3 to the power of 1 times 3, which is 3 to the power of 3. Then it'll become x to the power of 2 times 3, which is x to the power of 6. And you can see how these rules start to get kind of confusing, right? Now we're adding, we're multiplying, we're subtracting, we're doing all kinds of crazy things. When you have an exponent on an exponent, you multiply them. Awesome. Let's look at B. We have negative 2a squared b cubed all to the power of 2. Again, this negative 2 has an exponent 1. And a little invisible 1 there. So this square comes to all the exponents. When it goes to the negative 2, make sure you put the negative 2 in brackets. Because we still want it to be negative 2 that's getting squared. And we learned that in our calculators, if we don't put brackets, your calculator messes it up, right? So this would be negative 2 to the power of 1 times 2. That's negative 2 to the power of 2. A squared to the power of 2. So that would be a to the power of 2 times 2 becomes a to the power of 4. And then b to the power of 3 to the power of 2 becomes b to the power of 6. Fantastic. That's probably not how you see your final answer. Okay. How you probably see your final answer is they would actually evaluate that part or calculate it. Because that's an actual reasonable number to put in your calculator. If you put negative 2 squared in your calculator with brackets, you get 4. So your final answer is probably 4, a to the 4, b to the 6. It also means on the previous question, they probably would have done the same thing. They probably would have calculated 3 to the power of 3 to be 27. It's the same answer, just written differently. They've just evaluated the coefficient. Fantastic. All right, let's look at C. We now have x's on the top and x's on the bottom. When I have division questions where there's lots to do on the top and lots to do on the bottom, I break it into 2 parts. I'm going to deal with the top. I'm going to simplify anything I can on the top. Then I'm going to deal with the bottom. I'm going to simplify anything I can on the bottom. Then I'll try mashing the top and the bottom together. Okay, so for this question, looking at the top, I have x to the power of 3 times x to the power of 5. I would add the exponents. We have x to the power of 8. In the denominator, I have x squared times x to the power of 1. So we add the exponents to become x to the power of 3. Now it's a lot more manageable to just combine the top and the bottom. Right? It's back to like a basic question for us. So when we have division, we're subtracting the exponents. 8 minus 3 would be x to the power of 5. I find that's the best way to manage big questions as they get larger and larger. Awesome. For D, this negative sign. You guys learned something about negative signs. You learned that they float, right? So I would like to picture that negative as floating up to the 2. Okay, so it's not there anymore. It's now negative 2. Makes it easier to manage, in my opinion. Awesome. Now we have inside the brackets, and then we have an exponent outside. So that exponent has to come to every single term. And it multiplies by all the other exponents. In our case, the first one would be negative 2 to the power of 3, a to the power of 3, y to the power of 9. Right? Because 3 times 3 would be 9. Again, that's probably not how they write their answer, because they probably evaluate this part. They probably changed that thing I just circled in purple. So they put in their calculator negative 2 to the power of 3, and they get negative 8. And then everything else would stay the same. So you would get a to the 3, y to the 9. Awesome. Let's make it a little more challenging. Okay, it just keeps getting harder. Isn't that nice? Look at these guys. A's a little tricky. It's got like a negative outside the brackets and a negative inside the brackets. We're going to remember bed mass. So bed mass tells you the order in which you should do things. It's funny that Mr. Sake just said to talk about bed mass because we actually need to use it today. Okay, so if you don't remember, bed mass. Oh, see, this is where I would like to be able to write somewhere. Very nice deal. Open it here. Bed mass. Bed mass tells you that you should do brackets first, followed by exponents, followed by division, followed by multiplication, then addition, then subtraction. Awesome. Anybody use ped mass? That's actually the thing. Yeah, like it just depends on who your teacher was when you learned it, right? So ped mass is the exact same thing as bed mass, except it's parentheses, right, instead of brackets. Okay, so it's the same thing. Yeah, you remember that? Ped mass? Yeah. So it's the same thing, just instead of brackets, they call parentheses. Much more intellectual term, I guess. And so I'll always use BEDMAS because that's how I learned. When you're doing BEDMAS, brackets means inside the brackets you simplify, okay? Exponents then means if there's any exponents, you deal with them. So looking at this, inside the brackets, there's nothing that can be done. I just have negative n squared. Then I do exponents. I do have an exponent on an exponent, so I should deal with that. When I deal with that, the 5 will come in. So it will become n to the power of 10. You have this little negative sign here. That represents like a negative 1, right? So I would like to also give that 5 to that negative 1. So my current state would look like this. I'd have a negative sign from right there. And then I would have bracket. I'm going to do it in purple. Negative 1 to the power of 5. N to the power of 10. That negative 1 to the power of 5, you could calculate that, and it still just equals negative 1. Okay, but the reason we need to do it is because if we had an even exponent, it actually would have got rid of the negative symbol for us, which would have been nice. In this case, it doesn't. So I'm now going to rewrite it again. I have a negative up front still. All the purple stuff just turned to be back to negative. And then it's n to the power of 10. I just want you to be very aware that those negative symbols in front of letters could go away, right? Because if it was an even exponent, it would have gone away. In this case, it was an odd exponent, so it didn't go away. Fantastic. We've done our E on BEDMAS. Now we need to do any division. There is no division. Now we need to do some multiplication. There is multiplication here. Remember that this negative in front of the brackets is a negative 1. And brackets mean multiply. So I need to multiply these two negative 1s together, the two negative symbols. I'll do a different color here so it kind of sticks out of what I'm talking about. I don't want to create color. What's going on? Just use that. I wanted to do orange. Let me do orange. Red, even better. Okay, this is a negative 1 and a negative 1. They need to multiply together. Right? It's two coefficients. We just don't put the 1s. What would negative 1 times negative 1 equal? Positive 1. They kind of cancel each other out, right? And you're left with n to the power of 10. Positive 1 n to the power of 10. But we just don't write the positive. Negative symbols get very confusing. If you try to picture them as negative 1s, it might help. All right, let's look at B. B is kind of a crazy one. We're going to follow BEDMAS. Okay? That means simplify anything inside the brackets first. That's your goal. When we look inside the brackets, we've got some stuff on the top, some stuff on the bottom. I think it's easier to deal with the stuff on the top first. Then deal with anything on the bottom. Then match the two ideas together. So for us, that means on the top, I have 4 and 3 would multiply become 12. Y to the 3 and x to the 6 cannot combine because they're different letters. I prefer to write them alphabetically, so it becomes x to the 6, y to the 3. All divided by 6x to the 5. And it's still all to the power of 4. I'm still simplifying inside my brackets. I've only done the top and the bottom so far. Now I look at that thing. I have division. I can combine things using division. So let's look at numbers first. 12 divided by 6 would turn into 2. x to the 6 divided by x to the 5 would become x. And y to the 3 would still just be y to the 3. And it's all still to the power of 4. Can you guys see that light blue? Is it okay for you guys? Or some people are like, it's
No,
you can't see that? No, that's like super bright to me. I didn't think it was going to be that bright. I can barely see it when I'm up close. Sometimes the further away you are, though, it's easier to see. When you're up close, it's very bright. You'll notice by simplifying inside the brackets, look how much easier I made this 4 coming in. Okay, that's why I do it that way. That's why I follow bedmass. It'll make your life easier later on. Okay, to put in that kind of legwork. So, we take this 4 now, and we multiply it in. And it goes to every single term. That means it becomes 2 to the 4, x to the 4, y to the 12. Not bad, right? Just follow our steps. It's like having 4 questions in one. That's literally what it's like. Okay? We look at C. We got some craziness going on in C. We're going to follow bedmass. First thing, simplify anything in brackets that you can. We can't, right? These brackets don't have anything inside them that are the same. These brackets don't have anything inside them that are the same. Now we deal with any exponents outside of brackets that need to come into brackets. We do have that, right? We have this squared, which needs to come in. Notice that 16 is not part of the base, so 16 doesn't get the exponent. Right? 16 stays over. I then have x to the power of 3 times 2, which becomes x to the power of 6. And then I have y to the power of 5 times 2, gives y to the power of 10. All divided by. On the bottom, I had a different exponent that needed to come in. This one does go to the 2 because the 2 is inside the brackets. It's part of the base. That means it becomes 2 to the power of 3, x to the power of 6. Fantastic. We now have division, right? So we can move on to bedmass. We need to combine any division we can combine. In this case, we have 16 divided by 2 to the power of 3. You can put that in your calculator and it will work. If it's a decimal, you math frac it. In our case, it's not. 16 divided by 2 to the power of 3 should equal 2. I then have x to the power of 6 and x to the power of 6. When you do 6 minus 6, you get 0. Don't put x. When you put x, that has an invisible exponent of 1. We want 0. The way you represent x to the power of 0 is by not writing any x's. That's why you probably had teachers all the time who said they cancel out, right? Like those letters cancel out. They don't cancel out. They equal x to the power of 0. Anything to the power of 0 equals 1, and we don't write 1s. Okay, that's kind of why it happens the way it happens. Then you look at your y, you still have y to the power of 10. That's your answer. Yeah?
Would you lose marks if you put on one?
No. So if you put like 2 times 1 times y to the power of 10, no, you wouldn't lose marks. But I would want to see you simplify it, because then you have 2 coefficients, and then 2 times 1 equals 2. So I just want to see that simplification. Awesome. D. Oh, Moana, set the mood for math class. So we have this one right here. You're going to follow bedmass. So you look inside the brackets. There's nothing inside the brackets you can simplify. Right? They're all different letters, all different numbers. Then you do exponents. I do have an exponent that can come into the brackets. In this case, it goes to all those things. So I have 5 squared, a squared, b And then the other brackets didn't have an exponent, so they stay the same. I'm going to write the brackets again. You don't need to. Okay? If you don't put brackets, it just means I'll multiply. If you put brackets, it means I'll multiply. So it doesn't make a difference. Fantastic. When we do this question, we go coefficients with coefficients. 5 squared times 4 equals 100. You then look at your a's. We have a squared, a squared. They're multiplying together, so what do we do to the exponents? We add them to become 4. On the plus side, if you accidentally multiply them, you also get 4. And I have no idea what you did, so you just get a 1. 2's are nice like that. The last one, we have b to the 12, b to the invisible 1, would be b to the 13. Much bigger questions, not much harder questions if you know what you're doing, right? If you know the order and how to handle each question. The best way to get good at these things is just a lot of practice, honestly. All right, I don't think we need to practice those ones. I would like to do number 6. Number 5 is just kind of an exercise in negative numbers, okay, and in understanding how negatives work. Like, so for instance, this is negative 1 times a to the power of 6. So it would become negative 1 to the power of 6, a to the power of 6. And like, that's how they would want it to be viewed. And this one would become negative 1 to the power of 4, a to the power of 4. Okay, just remember that those negatives in front mean negative 1. So when the exponent comes in, it goes to the a n to the negative 1. The a n to the negative 1. Negative 1 to the power of 6, this guy, would equal 1. Negative 1 to the power of 4 would equal 1. Because they're even exponents, okay? Even exponents turn negatives positive. So you end up with 1 divided by 1, and then a to the 6 divided by a to the 4. 1 divided by 1 would just be 1. That cancels out. A to the 6 divided by a to the 4 becomes a squared. I won't do the other ones because we've talked a lot about negatives, and I've been taking my time on other questions with negatives. Okay, but just remember that it means there's a negative 1 there. We will try to tackle class example number 6. Particularly, B looks like it could be a lot of fun. Okay, so we'll do A. We'll do A pretty quick. You do inside the brackets, nothing can be done. We do exponents. 3 comes in. When it comes into the negative 2, I put negative 2 in brackets. So it's negative 2 to the power of 3, a to the power of 6, b to the power of 9. The other set of brackets, this set of brackets, had no exponent, so it just stays the same. 4, a to the 5, b to the 7. You'll notice this time I didn't write the brackets because I want to show you it's the same thing. Right? If I don't put brackets, all these things are still being multiplied together. If I put brackets around both things still, it just means multiply everything together. Okay? I just want to show you it's the same. Awesome. Coefficients with coefficients. Negative 2 cubed times 4 should become negative 32. A's with A's. A to the 6, a to the 5 become a to the 11. B's with B's. B to the 9, B to the 7. Add them to become B to the 16. That's not that bad. The last one, B, is kind of crazy, so we're going to do that one. Can you guys see the orange okay? That looks a lot better, right? Yeah. Okay, I'll avoid that nice light blue. Very pretty color, but not very math efficient. All right, let's look at B. That thing's mayhem. Okay, we got a big fraction. with a lot of stuff on the top and a lot of stuff on the bottom. The way we tackle it is look at the top, then look at the bottom, then combine the two. Okay, it'll make your life so much more manageable. On the top, I'm looking at just up here. I have an exponent on an exponent. Okay, I need to deal with that. So this 4 goes to the 2 and goes to the negative 1. That leaves me with 72, x to the 4, y to the 10, and then I have negative 1 to the power of 4, z to the power of 8. Okay, that's me multiplying the 4 into the brackets. In the denominator, so I'll work on the denominator at the same time since I'm rewriting all these things anyway. I have an exponent on an exponent as well. The 3 needs to come in. That leaves you with 6, 2 to the power of 3, x to the power of 3, y to the power of 6, z to the power of 8, y to the power of 3. Sorry, the tops of my x's and y's are connecting. The board doesn't like me writing small. Awesome. Across the top, we have more things that can still combine. Right? We've only dealt with the e in BEDMAS. Now we have some multiplication up there that can be handled. Looking at this thing, 72 and negative 1 to the power 4 are both coefficients. They can multiply together. When they multiply together, I get 72. The x's, y's, and z's cannot go together because they're all different letters. So I have x to the 4, y to the 10, z to the 8. All divided by. On the bottom, I have some things that can combine, right? I have some multiplication going on down there. I have 6 times 2 to the power of 3. I can put that in my calculator. I get 48. I also have some letters on the bottom that can combine. The x's can't, right? Because there's no other x's, so I have x to the 3. However, I have y to the 6 and y to the 3 to become y to the 9. I then also have z to the 8. That's a lot of math, right? So I took the top, I took my time, I broke it down. I took my bottom, I took my time, I broke it down. Now I match the two ideas together. So 72 divided by 48. I need to put that in my calculator. I need to go math frac. I don't think I know that one off the top of my head. Did anybody get it? Pardon? 3 over 2. Thank you very much. So those became 3 over 2. I then look at my x's. I have x to the 4 divided by x to the 3. I subtract my exponents to get x to the 1. I look at my y's. Y to the 10 divided by y to the 9. I subtract my exponents to give them y to the 1. I look at my z's. I have z to the 8 and z to the 8, which cancels out, right? Because they're both 8, so it should be z to the 0. We don't write z to the 0, right? Because z to the 0 equals 1. We don't write 1. Whew, that's a lot for combined exponent loss. Hey, so when we come back,